having studied about the photoelectric effect and the conclusions and the laws and various studies that we have taken up while studying this photoelectric effect, one thing that becomes very important, that this experiment or this particular experiment or this photoelectric effect phenomena, this actually doesn't go with the wave theory of light. So when we have studied the electromagnetic waves, we have told that light is nothing but wave, and then we have studied light as a wave, right? So if we think that light is a wave, then photoelectric effect or this kind of phenomena we cannot explain. So here becomes a confusion, and we see that the wave theory cannot explain, the concepts of wave theory cannot explain the photoelectric effect of light, because light is able to eject the electron out. And if we study the photoelectric effect with wave theory of light, that if light is a wave and then light is able to eject the electron out, then let's see what are the discrepancy and what would happen. The first thing is, if light were a wave and it tries to eject the electron out, then it would take several hours to several days for the wave to eject the electron out. So we cannot think, because the photoelectric effect is an instantaneous effect, doesn't even take much time. It's just instantaneous. So therefore, either the photoelectric effect, the explanation is not correct, or the wave theory of light is not correct. So there is a very big confusion over there, and therefore there is a failure of the wave theory of light when we are studying the photoelectric effect. The second thing is, if we see light as a wave, then the kinetic energy of the electrons should not depend on the frequency of the wave of the light. So but in photoelectric effect, what we see, that the frequency of the light that is falling, that is deciding whether the electrons would come out, and that is also deciding the stopping potential, that is also deciding the frequency, is also very much kind of affecting the kinetic energy of the electron, maximum kinetic energy of the electron that is coming out. But according to the wave theory, the frequency of the light cannot, because that is a wave, and the electrons, the kinetic energy of the electrons are particle, it's a material particle. So wave cannot have deciding factor, the frequency of the wave cannot have the deciding factor on ejecting, or the kinetic energy of the electrons that is coming out from the material particle. So if we are just thinking from the wave theory, then this is also a failure. And according to wave theory, the threshold frequency should not exist. So it means that according to the wave theory, it may depend on the intensity. If you if the intensity of the wave is more, it may have intensity factor on the kinetic energy of the electron. But what we see, the intensity absolutely have no factor. It doesn't even make any change in stopping potential, and it doesn't make any change in kinetic energy. Here, frequency of the wave is what deciding the kinetic energy as well as the stopping potential. But according to the wave theory, it is the intensity of light which should decide, which is not happening here. And if we go by wave theory, threshold frequency should not exist. Even if the lowest frequency, like the lower than threshold frequency, also at least few electrons should come out according to the wave theory. But what we see, below to the threshold frequency, there is absolutely no photoelectric current or photoelectric electrons are absolutely not ejecting out. So it is just a particular frequency of light, that is the threshold frequency, which is deciding whether photoelectric current effect will occur or not, which according to the wave theory is totally bizarre and should not happen. So therefore what we see when we are seeing the photoelectric effect is happening, then there is a failure of wave theory of light, and wave theory cannot explain the photoelectric effect.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.